Good day and welcome to today's class. In today's class, we'll be stating the fundamental theorem of calculus. The fundamental theorem of calculus is of two forms. The first form, which is called the first fundamental theorem of calculus, and then the second form, or the second version, which is called the second fundamental theorem of calculus. Second fundamental theorem of calculus. We'll be stating each one of these in different ways so that we can know what the theorem is all about and the different ways in which it can be stated. We begin with the first form. The first fundamental theorem of calculus. Fundamental theorem of calculus. That can be stated as: suppose f of x is continuous on the interval AB. Remember, it is a closed interval, and capital F of x is an antiderivative of f of x on the closed interval AB. Then the integral of f of x dx from A to B is equal to f of B minus f of A. This same theorem can be stated as suppose there is a finite set E and a function f such that the function capital F, which here is the antiderivative of f of x, is continuous on AB. The differential of capital F of x equals small f of x for all x element of AB, and 3 over the closed interval AB. Then the integral of f of x dx over the interval A to B is equal to f of B minus f of A. Another way whereby we can state this theorem: if the function f on the interval AB maps to R is continuous on the closed interval AB and differentiable on the open interval AB with a differential of capital F of x to be equal to f of x, where f on AB maps to R is Riemann integrable, then what? Then the integral of the function f of x dx over the interval a to b is equal to capital F of b minus capital F of a. Remember, we have said that capital F of x is the antiderivative of our function f of our function f of x. Those are the three ways in which we can state the first fundamental theorem of calculus. Now let's look at the second fundamental theorem of calculus and ways in which we can state it. Second fundamental theorem of calculus and the different ways in which we can state it. The first way, suppose f of x is a bounded and integrable function, defined on the closed and bounded interval AB. Closed and bounded interval AB. And a new function let's rub this off so we can have a place to write. And a new function, capital F of x. Remember, we have said capital F of x is the antiderivative of f of x. The new function, capital F of x, be defined such that capital F of x equals the integral of f of t dt from a to x, then it means that what? 1. Capital F is continuous on the closed interval AB. Capital F is differentiable on the open interval AB. And then lastly, the differential of capital F of x is equal to small f of x for all x elements of AB. This implies that capital F of x, the differential of capital F of x, is equal to d dx of the integral of f of t dt from a to x. And this is equal to f of x. We are stating what? The second fundamental theorem of calculus. Alternatively, we can state the theorem also as this. If f of x is continuous on AB, and capital F of x is the integral of f of t dt over the interval a to x, and is also continuous on AB and differentiable still on the open interval AB, then the differential of capital F of x is equal to d dx of the integral of f of t dt over the interval a to x, and that is equal to f of x. In this video, I have given us 3 ways in which the first fundamental theorem of calculus can be written or can be stated, and then 2 ways in which the second fundamental theorem of calculus can be stated. The second fundamental theorem of calculus can be stated as: suppose f of x is a bounded and integrable function defined on the closed and bounded interval AB, and a new function f of x be defined such that f of x is this, then it means that capital F of x is continuous on AB, capital F of x is differentiable on open interval AB, and the differential of capital F of x is equal to f of x for all x elements of AB. That's the first form in which you can state the second fundamental theorem of calculus. Alternatively, we can state it as: if f of x is continuous on the closed interval AB and capital F of x equals the integral of f of t dt from interval a to x, is also continuous on the closed interval AB and differentiable on the open interval AB, then the differential of capital F of x is equal to d dx of the integral of f of t dt from a to x, and that is equal to f of x. In our next video, we'll be looking at the proofs of the first fundamental theorem of calculus and the second fundamental theorem of calculus. Thank you. God bless you. I see you in the next video.